Franklin Vo. What is the chance of cryonics actually working? We don't know. Another factually incorrect answer calls it junk science that can never work, because cells contain water, which expands as it freezes, rupturing the cell membranes. Now, it's true that water expands as it freezes, which is why modern cryonics involves perfusing the person with cryoprotectants that replace the water. The person is then vitrified, that is, they go through a glassy phase transition. No water in the cells, no rupturing. This has been done with animal organs, which have then been reduced to liquid nitrogen temperature, warmed, and reimplanted in the animal, and shown to still be functional. Micrographical studies of tissues that have been vitrified and then warmed again show high-fidelity preservation of the tissue with no cellular rupturing. You'll hear people often tell you that cryonics can't work because water expands when it freezes. Generally speaking, these are people who heard that once 30 years ago and haven't kept up since then. Now, that doesn't mean it's a slam dunk. There are more problems to solve than just cellular damage caused by ice. One current outstanding problem, for example, is cracking. When you reduce large organs to liquid nitrogen temperatures, the organ doesn't cool uniformly. This can lead to cracking as the organ vitrifies. With the current state of the art, this cracking is unavoidable, and this is a problem that must be solved before anyone can be suspended and brought back. Another problem is cryoprotectant toxicity. Current cryoprotectants are toxic. Specifically, they cause pores to open in blood vessels, so an organ that's vitrified and then warmed again can leak blood. This is another problem that must be solved before cryonics is viable. Is it theoretically possible to solve these problems? Yes, it is. For a long time, people said flight was impossible, even though birds fly. Lord Kelvin was one of those who believed human heavier-than-air flight was impossible. The thing is, there are animals that survive being completely frozen solid. Generally, they handle the problem of cellular rupture by using glucose molecules as cryoprotectants. Wood frogs, Rana sylvatica, can survive this way and come back to life when they thaw. Takeaway here: as a general rule, it's dangerous to label something impossible when we can look in nature and see animals doing it. Smiley face. Cryonics violates no laws of physics. Animals exist that can tolerate being frozen through. What is the chance of cryonics actually working? Given the current state of the art, poor. If I were a betting man, I'd bet 80-20 against. What is the chance of cryonics eventually working? High to almost certain. If I were a betting man, I'd give odds better than 99-1 in favor, largely because we see animals that can do it, so we know for a fact it's biologically possible. What is the chance of cryonics eventually working to the point where you can live for high centuries or even thousands of years in suspension? Effectively zero. At liquid nitrogen temperatures, chemical processes basically stop, but nuclear processes do not. Ordinary background radiation damage continues to accumulate just from normal sources of everyday environmental radiation and cosmic radiation, And when you're frozen, the normal DNA repair mechanisms stop working. A person in stasis continues to receive background radiation damage, but can't repair it. Eventually, given hundreds of years in stasis, such a person accumulates a lethal amount of radiation damage. So, bet against anyone who tells you it's impossible, but also bet against anyone who tells you can wake up 1,000 years from now. 238.6K views. View 5,489 upvotes.